to one and all present for today's International Science webinar. I am Mrs. Megha S. Upadhyay, Faculty, Department of Biotech. Before we start with today's session, I would like to put forth a couple of instructions. The first instruction is, I would request all the participants to keep your microphones on mute. The second instruction is, question and answer session will be held at the end of the session, so please be ready with all your questions. The third one is, the feedback link will be posted in the chat box. I request all the e-participants to fill the feedback form for the certificates. Good morning once again to all the e-participants present for today's International Science webinar. Science is a way of thinking much more than it is a body of knowledge. Today, we are here to enlighten ourselves and learn more about science through this International Science webinar organized by Science Forum, Scientia, S.J.R, Bangalore. It's my great honor to welcome our today's resource person, Shri Arun Kumar Sir, Lead Scientist, KSA Analyst, SABIC Technology Center, Jubail, Kingdom of Saudi Arabia. We welcome you, sir. I would also like to welcome our second speaker, Sri Radhakrishna Neelakanta, Senior Manager, Cathlab, Sakraworld Hospital. It's my great pleasure to welcome Dr. Kamala YC Ma'am, Associate Professor, the National College, Bengaluru. We welcome you, ma'am. A warm welcome to our beloved principal, Dr. Prema Siddaraju ma'am, who has been a great support to us in organizing all the programs. We welcome you, ma'am. A hearty and warm welcome to all the faculties and students attending today's Science International webinar. I welcome all the participants today. I'm sure that today's talk will surely help all of us in understanding the facts in science. Now, I would request our principal ma'am, Dr. Prema Siddaraju, for the keynote address. Over to you, Prema ma'am.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಈ ದಿವಸ ನಮ್ಮ ಕಾಲೇಜಿನ ವಿಜ್ಞಾನ ವಿಭಾಗದವರು ಸೈಂಟಿಯಾ ಫೋರಂ ಇಂದ ಆಯೋಜಿಸಿರುವಂತಹ ಅಂತಾರಾಷ್ಟ್ರೀಯ ವೆಬಿನಾರ್ ನಲ್ಲಿ ಭಾಗವಹಿಸಿರುವ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ ಮಾಡ್ತಾ, ನಮ್ಮ ಈ ಒಂದು ಅಂತಾರಾಷ್ಟ್ರೀಯ ವೆಬಿನಾರ್ಗೆ ಕರೆಗೆ ಹೋಗೊಟ್ಟು ಬಂದಿರುವಂತಹ ಅರುಣ್ ಕುಮಾರ್ ಸರ್ ಅವರೇ, ಮತ್ತೊಬ್ಬ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ ಆಗಿರುವಂತಹ ರಾಧಾಕೃಷ್ಣ ನೀಲಕಂಠ ಅವರೇ, ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದ ಅಧ್ಯಕ್ಷತೆಯನ್ನ ವಹಿಸಿಕೊಳ್ಳಲು ಒಪ್ಪಿರುವಂತಹ ಡಾಕ್ಟರ್ ಕಮಲಾ ವೈಸಿ ಮೇಡಮ್ ಅವರೇ, ಹಲವು ಕಾಲೇಜುಗಳಿಂದ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಜಾಯ್ನ್ ಆಗಿರುವಂತಹ ಹಲವಾರು ಪ್ರಾಧ್ಯಾಪಕ ವೃಂದದವರೇ, ನನ್ನೆಲ್ಲ ಸಹೋದ್ಯೋಗ ಮಿತ್ರರೇ ಮತ್ತು ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿನಿಯರೇ, ಇದೊಂದು ವಿಶೇಷವಾದಂತಹ ಒಂದು ವೆಬಿನಾರ್. ನೀವೆಲ್ಲ ಕೇಳಲೇಬೇಕಾಗಿರುವಂತಹ, ತಿಳ್ಕೊಳ್ಳೇಬೇಕಾಗಿರುವಂತಹ ಒಂದು ಸಂದರ್ಭ. ಯಾಕೆ ಅಂದ್ರೆ ನಮ್ಮಲ್ಲಿ ಇತ್ತೀಚೆಗೆ PUC ನಲ್ಲಿ PMCS, PMC, ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸು, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸು, ಈ ರೀತಿಯಾಗಿ ಸೈನ್ಸ್ ಅನ್ನ ತೆಗೆದುಕೊಂಡು ಅಧ್ಯಯನ ಮಾಡಿದಂತಹ ವಿದ್ಯಾರ್ಥಿನಿಯರಿಗೆ ಒಂದು ಮೂಲಭೂತವಾಗಿ ಒಂದು ಪಿಡುಗು ಕಾಡಿದೆ. ಏನಂದ್ರೆ, ನಾವು MBBS ಮಾಡಿದ್ರೇನೆ ವಿಜ್ಞಾನಕ್ಕೆ ಅರ್ಥ, ಇಂಜಿನಿಯರಿಂಗ್ ಮಾಡಿದ್ರೇನೆ ವಿಜ್ಞಾನಕ್ಕೆ ಅರ್ಥ ಅಂತ. ಆದ್ರೆ ನೀವು ಗಮನಿಸ್ಬೇಕು, ಇವತ್ತು ಬಂದಿರುವಂತಹ ಇಬ್ರು ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ಗಳು ಏನಿದ್ದಾರೆ, ಅವರು BSc ಯನ್ನ ಮಾಡಿ ದೊಡ್ಡದಾದ ಸಾಧನೆಯನ್ನ ಮಾಡ್ತಾ ಇರುವಂತವ್ರು. ಅವರು ವಿಜ್ಞಾನ ಕ್ಷೇತ್ರದಲ್ಲಿ ತಾವು ಅಂದ್ಕೊಂಡ ಹಾಗೆ ಸೈಂಟಿಸ್ಟ್ ಗಳಾಗಿ ಸಮಾಜಕ್ಕೆ, ದೇಶಕ್ಕೆ ಸಾಕಷ್ಟು ಕೊಡುಗೆಯನ್ನ ಕೊಡ್ತಾ ಇರುವಂತವ್ರು. ಹಾಗೆ ಅಧ್ಯಕ್ಷತೆಯನ್ನ ವಹಿಸಿರುವಂತಹ ಡಾಕ್ಟರ್ YC ಕಮಲಾ ಮೇಡಮ್, BSc, MSc, ಡಾಕ್ಟರೇಟ್ ಮುಗಿಸಿ ವಿದ್ಯಾಕ್ಷೇತ್ರದಲ್ಲಿ ದೊಡ್ಡ ಸಾಧನೆ ಮಾತ್ರ ಅಲ್ಲ, ಸಾಹಿತ್ಯ ಕ್ಷೇತ್ರದಲ್ಲಿ ವಿಶೇಷವಾಗಿ ವಿಜ್ಞಾನವನ್ನ ಕನ್ನಡದಲ್ಲಿ ಒಂದು ಬರೆಯುವಂತಹ ಅಥವಾ ಓದುವಂತಹ ಒಂದು ವಿಶೇಷವಾದ ಕಾರ್ಯಕ್ಕೆ ತಮ್ಮನ್ನ ತೊಡಗಿಸ್ಕೊಂಡಿರುವಂತವ್ರು. ವಿಜ್ಞಾನ ಕನ್ನಡ ವೇದಿಕೆಯ ಅಧ್ಯಕ್ಷರು ಕೂಡ ಆಗಿರುವಂತವ್ರು. ಆಮೇಲೆ ನೀವ್ ಏನು ಇವತ್ತು ನೋಡ್ತಿದ್ದೀರಿ, ಅರುಣ್ ಕುಮಾರ್ ಆಗ್ಬಹುದು, ರಾಧಾಕೃಷ್ಣ ಅವರಾಗ್ಬಹುದು, ಅವರೆಲ್ಲ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಓದಿ ಬೇರೆ ಬೇರೆ ದೇಶಗಳಲ್ಲಿ ಉತ್ತಮ ಸೇವೆಯನ್ನ ಮಾಡ್ತಾ ಇರುವಂತವ್ರು ವಿಜ್ಞಾನ ಕ್ಷೇತ್ರದಲ್ಲಿ. ಈ ಹಿಂದೆ ಕೂಡ ನಾವು ಒಂದು ಸೈನ್ಸ್ ವೆಬಿನಾರ್ ಅನ್ನ ಮಾಡಿದ್ವಿ. ಆವಾಗ ಆಗಮಿಸಿದ್ದಂತಹ ನಮ್ಮ ಬಸವರಾಜು ಸಂಗನಹಳ್ಳಿಯವರು, ಅಮೆರಿಕದ ಯಾಲೆ ಯೂನಿವರ್ಸಿಟಿನಲ್ಲಿ ಇರುವಂತವ್ರು, ಅವರು ಕೂಡ ಮೂಲ BSc ಓದಂತವ್ರು. ಹಾಗೇನೆ ಮಂಜುನಾಥ್ ರೆಡ್ಡಿ ಸರ್ ಅವರು ನ್ಯೂಜಿಲ್ಯಾಂಡ್ ಅಲ್ಲಿ ಇರುವಂತವ್ರು, ಅವರು ಕೂಡ BSc ಪದವಿಯನ್ನ ಪಡ್ಕೊಂಡು ಮುಂದಿನ ಸಾಧನೆಗಳನ್ನ ಅವರ ಗುರಿಗೆ ತಕ್ಕ ಹಾಗೆ ಮಾಡ್ಕೊಂಡಂತವ್ರು. ಈ ಮಾತು ನಾನು ಯಾಕೆ ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ, ಬೇಸಿಕ್ ಆಗಿ ನೀವು ವಿಜ್ಞಾನವನ್ನ ಕಲಿಬೇಕು ಅಂದ್ರೆ, ಈ ಸೈನ್ಸ್ ಅನ್ನ ನೀವು ತಗೊಂಡ್ರೆ, BSc ಪದವೀಧರರಾದ್ರೆ ಮುಂದೆ ನಿಮಗೆ ಹಲವಾರು ಅವಕಾಶಗಳಿರ್ತವೆ. ಬರೀ ಯಾಕೆ ಒಂದು ಕಟ್ಟುಪಾಡಿಗೆ ಒಳಗಾಗ್ತೀವಿ ನಾವು, BE ಮಾಡ್ಬೇಕು, MBBS ಮಾಡ್ಬೇಕು, ಈ ಮನೋಭಾವನೆಯನ್ನ ಹೊರ ಹಾಕೋಬೇಕು. ಜೊತೆಗೆ ಇವತ್ತು ಮಾದರಿಯಾಗಿರುವಂತಹ ಈ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ ಗಳನ್ನ ನೀವು ಗಮನಿಸಬೇಕು. ಈ ದೃಷ್ಟಿಯಿಂದ BScಗೆ ಯಾವುದೋ ಒಂದ್ ರೀತಿನಲ್ಲಿ ಕೀಳರಿಮೆ ಇಟ್ಕೊಂಡಿರುವಂತಹ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಮತ್ತು ಈ ಕೀಳರಿಮೆಯನ್ನ ಹೋಗಲಾಡಿಸಬೇಕಾಗಿರುವಂತಹ ಪ್ರಾಧ್ಯಾಪಕರಿಗೆ ಬಹುಶಃ ಈ ಒಂದು ವೆಬಿನಾರು ಮತ್ತೆ ನಮಗೆ ಬೇಸಿಕ್ ಆಗಿ ಬೇಕಾಗಿರುವಂತಹ ಮನುಷ್ಯನ ಬದುಕು ವ್ಯವಸ್ಥಿತವಾಗಿ ನಡಿಬೇಕಾದ್ರೆ, ಉತ್ತಮ ರೀತಿಯಲ್ಲಿ ಬೆಳವಣಿಗೆಯನ್ನ ಹೊಂದಬೇಕಾದ್ರೆ, ಅಥವಾ ಪ್ರಪಂಚದಲ್ಲಿ ಹಲವಾರು ಸೌಲಭ್ಯಗಳನ್ನ, ದೈಹಿಕ ಆರೋಗ್ಯ ಇರಬಹುದು, ಅಥವಾ ಸಾಮಾಜಿಕ ಸ್ವಾಸ್ಥ್ಯ ಇರಬಹುದು, ಅಥವಾ ಯಾವುದೇ ರೀತಿಯ ಅನುಕೂಲಗಳು, ಆಧುನಿಕ ತಂತ್ರಜ್ಞಾನ, ವಿಜ್ಞಾನ ಇವೆಲ್ಲವೂ ಕೂಡ ಮುಂದುವರಿಬೇಕಾದ್ರೆ ಮೂಲಭೂತವಾದಂತಹ ಈ BSc ಪದವಿ ಅನ್ನುವಂಥದ್ದು ಎಷ್ಟು ಮುಖ್ಯವಾದದ್ದು. ಮತ್ತು ಅವರು ಮಾಡ್ಕೊಳ್ತಾ ಇರುವಂತಹ ಬೇರೆ ಬೇರೆ ಕ್ಷೇತ್ರದ ಸಾಧನೆಗಳು, ಅದು ಹಾರ್ಟಿಗೆ ಸಂಬಂಧಪಟ್ಟದ್ದಿರಬಹುದು, ಅಥವಾ ನಮ್ಮ ಅನಾರೋಗ್ಯಗಳಿಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ಏನ್ ಔಷಧಿಯ ಕೆಲವೊಂದು ಔಷಧಿಗಳು ನಮ್ಗೆ ಬೇಕು ಅವುಗಳನ್ನ ಕಂಡು ಹಿಡಿಯುವಂಥದ್ದು, ಇವೆಲ್ಲವನ್ನ ಒಳಗೊಂಡಂತಹ 2 ವಿಚಾರಗಳನ್ನ ಒಳಗೊಂಡು ಇವತ್ತು ವೆಬಿನಾರ್ ಇದೆ. ಒಂದು ಅನಾಲಿಟಿಕಲ್ ಇಂಡಿಪೆಂಡೆನ್ಸ್ಟಬಲ್ ಸೈನ್ಸ್ ಅನ್ನುವಂತ ಒಂದು ಟಾಪಿಕ್ ಆದ್ರೆ, ಇನ್ನೊಂದು ಕೊರೋನರಿ ಆರ್ಟರಿ ಡಿಸೀಸಸ್ ಅಂಡ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಅನ್ನುವಂತಹ ವಿಚಾರ. ಈ 2 ವಿಚಾರಗಳಿಗೆ ಸಂಬಂಧಪಟ್ಟ ಹಾಗೆ ಅವರಿಬ್ರು ವಿಜ್ಞಾನಿಗಳು ಅವರದೇ ಆದಂತಹ ಒಂದು ಸಾಧನೆಯನ್ನ ಮಾಡಿದ್ದಾರೆ, ಸಾಧನೆಯನ್ನ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಅವರು ಹೆಸರು ಮತ್ತು ಹಣ 2 ಕ್ಷೇತ್ರದಲ್ಲಿ ಉತ್ತಮ ಸ್ಥಾನದಲ್ಲಿ ಇರುವಂತಹ ಇಬ್ಬರು ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ಗಳು. ಅವರನ್ನ ನಾನು ನಮ್ಮ ಕಾಲೇಜಿನ ಪರವಾಗಿ, ನಮ್ಮ S.J.R ವಿದ್ಯಾಸಂಸ್ಥೆಯ ಪರವಾಗಿ ಮತ್ತೊಮ್ಮೆ ಅವ್ರಿಗೆ ಸ್ವಾಗತವನ್ನ ಕೋರ್ತಾ, ನಮ್ಮ ರಾಜ್ಯದಲ್ಲಿ ದೊಡ್ಡ ಹೆಸರನ್ನ ಮಾಡಿರುವಂತಹ ಡಾಕ್ಟರ್ YC ಕಮಲಾ ಮೇಡಮ್ ಅವರು, ನೀವು ಗಮನಿಸಿರ್ತೀರಿ ಅವ್ರನ್ನ, ಯಾವುದೇ ಟಿವಿನಲ್ಲಿ ಗ್ರಹಣದ ವಿಚಾರ ಬಂದಾಗ ಕಮಲಾ ಮೇಡಮ್ ಇರ್ತಾರೆ. ವೈಜ್ಞಾನಿಕವಾಗಿ ಆ ಒಂದು ಗ್ರಹಣವನ್ನ ವಿಶ್ಲೇಷಣೆ ಮಾಡೋದ್ರಲ್ಲಿ ಸದಾ ಮುಂದಿರ್ತಾರೆ. ಅಷ್ಟು ಮಾತ್ರ ಅಲ್ಲ, ಕನ್ನಡದಲ್ಲಿ ವಿಜ್ಞಾನ ಸಾಹಿತ್ಯವನ್ನ ರಚನೆ ಮಾಡೋದ್ರಲ್ಲಿ ನಮ್ಮ ರಾಜ್ಯದಲ್ಲಿ ದೊಡ್ಡ ಹೆಸರು ಕಮಲಾ ಮೇಡಮ್ ಅಂತ ಅವ್ರದ್ದು. ಸೊ ಈ 3 ಜನ ನಮ್ಮ ಈ ಒಂದು ವೆಬಿನಾರ್ಗೆ ಅತಿಥಿಗಳಾಗಿ, ಅಧ್ಯಕ್ಷರಾಗಿ ಒಪ್ಪಿ ಬಂದಿರೋದಕ್ಕೆ ನಾನು ಬಹಳ ಕೃತಜ್ಞತೆಯನ್ನ ಅವ್ರಿಗೆ ಸಲ್ಲಿಸ್ತೇನೆ. ನನಗೆ ವಿಜ್ಞಾನದ ವಿಚಾರಗಳು ಹೆಚ್ಚು ತಿಳಿದೇ ಇರೋ ಕಾರಣಕ್ಕೆ ಪ್ರಾಸ್ತಾವಿಕವಾಗಿ ಇಷ್ಟು ಕೆಲವು ಮಾತುಗಳನ್ನ ಹೇಳ್ತಾ, ಈ ವೆಬಿನಾರು ಅಚ್ಚುಕಟ್ಟಾಗಿ ನಡೆಯುತ್ತೆ ಅನ್ನೋ ಮಾತುಗಳನ್ನ ಹೇಳ್ತಾ, ಶುಭವನ್ನ ಕೋರ್ತಾ, ಬಂದಿರುವ 3 ಗಣ್ಯರಿಗೆ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸ್ತಾ ನನ್ನ ಕೆಲವು ಮಾತನ್ನ ಮುಗಿಸ್ತೇನೆ. ಧನ್ಯವಾದ.
ಧನ್ಯವಾದಗಳು ಪ್ರೇಮಾ ಅವರೇ.
Thank you, Prema ma'am. Now I would request Manjula SN, Faculty, Department of Physics, to introduce the guest. Over to you, Manjula ma'am.
Thank you, Madam. Good morning, everyone. It's a great pleasure to be able to introduce the resource person, Shri Arun Kumar S, for International Science Webinar. Arun Kumar sir is a dynamic professional with over 13 years of rich experience in research and development. He has extensively worked on laboratory operations, quality assurance and documentation, sales of new analytical products of atomic spectroscopy, such as inductively coupled plasma optical emission spectroscopy, atomic absorption spectrometry, mass spectrometry. These are the spectrometry products of UV and FTIR, which are the techniques for measuring quantities of chemical elements present in the samples. After completing master's degree in inorganic chemistry from Bangalore University in 1996, Sir worked as a chemist at Raleigh's Research Station, Bengaluru, where he engaged in the analysis of raw materials and finished products through wet chemical and instrumentation methods. He has extended valuable support to the product development department for new formulations. During 1998 to 2001, he worked as a junior scientist with Shiva Analytical India Limited and published a paper on determination of trace impurities in high pure chromium matrix with matrix removal process by ICP-MS, that is inductively coupled plasma optical emission spectroscopy at 8th International Symposium on Mass Spectrometry held at IICT, that is Indian Institute of Chemical Technology, Hyderabad. Sir has developed the ICP-MS method for detecting platinum group of elements in environmental and geological samples. From 2001 to 2007, he worked as research scientist with GE India Technology Center Private Limited, Bengaluru, rendering analytical support to the research and development team and global manufacturing team for GE Plastics, GE Silicons, and GE Water and Process Technology. Sir has involved in developing ICP methods to quantify the metal impurities and the byproducts formed during the monomer synthesis process. From 2007 to 2015, Sir worked as ICP-MS expert, that is inductively coupled plasma optical emission spectroscopy expert with Agilent India Technologies Private Limited, Bengaluru. Presently, Sir is working as a lead scientist with SABIC Technology Center, Jubail, Saudi Arabia. Arun Kumar Sir is proficient in maintenance and calibration of various analytical equipments as well as enhancing productivity, developing formulas for new products and reformulations using analytical methodologies, utilizing techniques like failure methods and effects analysis, design of experiments, analysis of variance, quality function deployment to ensure that analytical methods are precise, accurate, reproducible, and specific in adherence to the Food and Drug Administration guidelines. Sir has actively involved in data management designing for GE Plastics at Netherlands for handling scientific data resource and optimization of product launch. Sir has received various awards and recognitions. During 2003 to 2006, Sir has received 2 US patents and 2 European patents as a co-author for GE in monomer purification and scale-up process. He has received twice restricted stock units from Elegant Technologies in recognition for increasing sales with the help of sales team across the country. In 2010, Sir has received President Club Award for Best Sale and Continuous Increase of Market Share of Inductively Coupled Plasma Mass Spectrometry. We are very happy to have you with us for today's session. We welcome you once again, sir, to this International Science webinar. Over to Megha Madam.
Thank you, Manjula ma'am. It's a real honor to have Shri Arun Kumar sir for today's session. So the first topic for the session is Analytical Indispensable Science. I would like to request Shri Arun Kumar sir to start the session. Over to you, sir.
Yes, ma'am. Can you see my slides?
No, sir, the slides are not visible.
No?
No,
Yes, sir, it's visible.
Okay.
You have to pin search screen.
Yeah. Now it's visible.
Yes, sir, it's visible.
Okay, thank you very much. First, I thank Manjula ma'am for her extensive. I didn't know so much of thing has been done, but she refreshed my memory what I have done over a period of time. Thank you, ma'am. Really, you have done a lot of work on searching out what I have done for until now. It is a very small thing, but I think all the good things goes to our gurus who taught us all this lesson over a period of time. With this note, I first greet everybody for Deepavali, the festival of light, and the light will be with everyone, and the knowledge will grow, and all Indian scientists will grow across the nations. And with that, I start my presentation today. I'm audible, correct? Is it?
Yes, sir.
All right. Okay. Analytical, indispensable science. If I want to start with instead of chemistry, if I see as a child takes birth, and after a couple of days, if mother sings a song or touches the baby, already the baby recognizes it is her or his mother. That is the way the sensibility of analytical starts in humans. Within 2 days, the baby starts. Even it may be much earlier also. But what I have experience out looking at, when any mother sings, the baby is silent when it is crying. It shows the way the brain analyzes the sound or whatever. That's the way the analytical comes into play. Coming to the chemistry point of view, today's presentation is with respect to what I'm going to cover is looking at the attendees. When I talked to Madam, she told it's undergraduation and we have to encourage them to go to higher studies, and based on which I built upon the analytical techniques and how these analytical techniques makes your life and the work more interesting for you to bring knowledge as well as your own involvement into the science. In those areas, I have taken the instrumentation, the chemical approach, the spectroscopy. Few instruments I have included in that, thermal, and as well as the chromatography. To start with, I would like to share what is SABIC, which I am working for now as a SABIC Technology Center. We are the global leaders in the fuel production as well as the polymer production for the entire world. Our polymers have been used in different applications, right from you can take the medical application as well as in the aeroplanes where the fuel efficiency is required. The inner parts of the plane where it can be replaced by the plastic, where the weight comes down and the fuel efficiency increases out, and as well as the foam. Take any of the application which uses the plastic, SABIC is producing that, and we are serving our customers to have functional polymers as well as required polymers with whatever their requirement with respect to it. May be a hardness, it may be tensile strength requirement, or it may be laptop with a high strength ones, as well as I told you in the flights and all the other applications. Coming to what SABIC across the globe, we established in 1976, and approximately around 34,000 employees are working around the world. We have the operations around 50 countries, and third largest chemical company in the world, and 120th public company in the world. We have four core businesses which we run. Approximately around 86 US billion is the assets of the company, and net income of 4.9, and around annually we get around 39.9 US billion production. In doing all this, what we have to do is always look for the new, what customer is requiring, what is the upcoming, like what are the new innovations are happening, and what is the customer requirement for tomorrow. As the world is going towards the miniature thing, then the plastics also has to relate to that. Hence, the new products have been invented for that. And always there is a patent which protects the intellectual property of the company. Hence, every year there is a patent filings and other things which we do along with the product. And we have 64 world-class plants which produces polyethylene, polypropylene, and so many other grades of the plastics, which caters the need of the requirement of the world. With this prelude, I just go to my topic of today. One more slide. All these products, what I said about 150 products or new products, cannot be done without a global research center or innovation center. And hence, we have all the innovation centers across the world as well. In India, if I want to say, it's in Sajapur. Is next to, is around, I think so, 30 kilometers away from the city. There is a global research center. One can have a visit and see how we do the plastic research as well in some time, if after a particular protocols have been followed during. Okay. With this, I start my today's session. What impact in today across the world? It's from early ages as well as now. Food, water, air, and shelter. These are the four things which is today as well as tomorrow. It keeps on growing and growing. As the population increases, there is always a need for it. And yeah, due to some environmental condition, due to some conditions across the world, there is a scarcity for those. And as well as everyone has experience about the COVID, the healthcare is not to be told. Everyone knows about that now, and the medical about the medicine. And the next speaker will speak about those parameters as well coming forward. And in all this, when we want to grow the plant, when we want to have a good harvest, or when we want to have small kids across the world to have their food and go to school, we should have a good products to introduce, like using the manure to the good manures to the plant, not to have too much of herbicide or pesticides inside in those. So that in the earlier session, what has been arranged by Prema ma'am, one of the speakers told about how a farmer goes and sprays the insecticides or the pesticides, how his health is getting affected, and based on the antidotes, how he is recovering out. And those results have been has been talked about in this type of seminars. Hence, what is important is, in all the cases, the quality and availability. How the product quality is there, if the medicine is prepared, how safe is it for the individuals, as the discussion is happening about the vaccination of the COVID, how safe is it, and whether they are following all the protocol. And as well, everyone knows about the availability, how it is been manufactured across the world. Every research institute is working on those such that the product is available in the market. And the quality and availability is governed by the government and organization which implement the policies to make the smooth process for the public. Quality as such is a property of the characteristic of the substance or the services which is obtained or provided. When the quality, if you want to have a better quality of the product, hence you have to. Hello? Okay. I continue. Over a period of time, the quality also has changed. Quality also has changed its requirement based on the society's requirement. When I was working in Agilent, I remember still the milk in a certain part of the world has been polluted with melamine. We were analyzing those to see whether the melamine is mixed with that. Why? Because there was a huge amount of nitrogen in melamine. The mothers used to think, oh, this milk is having more protein, and then they used to feed the babies. But it was the different cause of the high protein nature in the milk at that time. Everyone knows about the adulteration in the oils. Water quality is one of the biggest across the world, which is having a concern. Medicine and its purity, and all the pharma manufacturers who are producing take utmost care to produce the quality products, and they undergo very stringent audit by FDA and ICH, using ICH guidelines and other things. As well as the food, as I told about the pesticides and insecticides, which are being tested for, then there is an export across the world. And in all this, one of the important case also comes is where the material of construction, where the plant is in the plant, how much, what is the material of construction, whether it is undergoing corrosion, whether it is withering out during the production, all this comes into play. Hence, the quality is being monitored by certain agencies across the world. One of these is FSSAI in India, which is Food and Safety Authority of India, and the European Commission regulations, where when anybody from India exports out, for example, from the Kerala and Cochin part, they export too much of fish or the marine products to the Europe, as well as when there is a grape season, the grapes have been sent across. Hence, each and everything has been checked for pesticide as well as antibiotics in those cases. As I told you earlier, the Food and Drug Administration has its own protocols to check for the manufacture of the medicines. EPA guidelines are there for few of the regulations where it has to be followed when there is a huge shipment across the world reaching the European Union, as well as the peoples across the world have used this as a guideline, and they also monitor those in their countries. With this all, what it brings it to the analytical person is how should I sample it? If I see the samples, it is gamut. It's going from water to the milk, which is high protein, maybe protein over here, or the oil with too much of fatty acids over there. Medicines, if it is anti-cancer drugs, which is platinum-based drugs also, and going to the food, which is a gamut of samples. What makes it interesting for a chemist or the chemistry person to learn? Where should I sample? When I should sample, and how should I sample? These are the three questions one has to ask with respect to while sampling out the in the market or in any of the regions. What is the period of sampling? How should I sample? Second, what are the type of equipments I have to sample? For example, if I'm taking water and I use something like a glass beaker or a plastic beaker, does the quality changes when I measure any component of it? That's the question one has to ask. Or if I have the volatile organic carbons, for example, I think all the chemistry persons knows about acetone or ethanol because it's used in the nail polish, or nowadays it's used in the sanitizers. When methanol or ethanol is being sampled, what type of equipments I should use? One has to be careful about that. And methods used for those analysis. What tests to be conducted? What is the importance of these tests? If I'm testing any product, for example, anti-cancer drug itself, how much of palladium is there, how much of platinum is there any isomer of the platinum is there, is it by any clinical trials, is it being proven that this isomer is problematic for a patient? Is there any research has been done? All this has been considered and would be considered over there. And what is the importance of when you generate a results, what is important to the customer? What he sees in value in your results. For example, if anybody is exporting a marine fish or anything, they look at lead, cadmium, arsenic, mercury. These are the toxic metals which we have a very stringent specification from the Europe. the most importance would be given by the customer in those screenings also when coming to the marine products. As I told, the equipments or the material used for sampling is also important during those steps. When it is a sample, there is the sample identification from the bulk. With this, what I want to say is, suppose in any of the listeners, the students who become tomorrow a CEO or a MD of a company, they want to run a business and they want to have a catalyst to be imported from outside. If they are importing around 5,000 kgs, how much, if they ask whether this quality is correct, they will send a small amount of sample. How the sampling can be done from the bulk 5,000 kgs to 50 grams, what you get as a sample, how the bulk samples has to be done, how the sample collection has to be done, how to segregate those samples and send it to the analytical lab in your company, or it may be commercial lab for the testing that one has to have. And these are the three external process. That means outside the analytical department, what happens. And all this external process, if you as an analytical person don't educate them, they can bring up a lot more contamination to the sample and you can fail the sample also. That is the one drawback which I have seen over a period of time. And it is required to educate them as well during those processes, the sampling as well. And once you receive the sample, how it can be preserved. And everyone knows about how in the kitchen, how food is preserved. And in the similar way, the chemicals has to be preserved, like volatiles has to be kept at lower temperature conditions and in the fridge or the cold conditions, as well as when it is a pyrophore, it should be away from the fire and other things. One has to take care of all those, assigning the sample to individual sections. And while analyzing, you have to follow certain standard operating procedures. SOP means standard operating procedures. And this may be in-house, or it can be also called test method, which is being developed in-house by the individual company. STM is one of the standards which has been internationally renowned for so many products across the world, as well as UOP, USP, and EP. These are the some of them have the SOP, some of them have the guidelines. We use all this in our processes to see whether the sample is good or bad, whether the sample is meeting the specification or not. And once you generate the data, a central repository for the publishing the results. Why? Because why it is important, as I see today, a lot of people earlier 1 year back used to go back to the clinic to take their reports, but today they put it on the website. Please don't come look at your website, you will have your report. That is the way the change has happened. Similar change was happened few years back, a few decades back, about the analysis, where people see they publish their links in the reports in the links or the external portals, so that the customer can see those. What are the terminologies I use in analytical science? When I analyze, I take the substance and look for its constituents of the in the process. What are analytes? They are the ones which are interesting in the sample. For example, if I take I gave an example of melamine in milk. Melamine is an analyte, and milk is known to be as a matrix. That is a major composition of the sample is called the matrix. And we have procedures and test methods which contains the instruction of the instrument calibrations as well as how to analyze the sample. All instruction will be given. Once you are following all this, when you come to the test method, there are method quality parameters. Just I have a question for some who are online. Can you see the red dots in the slide anywhere? I will wait for the answer. Hello? Can you see, anybody can see red dots in the slide?
No, sir. Red patch is seen. The third one.
Okay. You can see the red dots here? Where my cursor is? Very light. Okay. Maybe due to I'm not able to see. I have pasted
It's very minute.
a red. Yes,
Yes, sir, we can see.
for a
There are
reason.
3
I will tell you.
dots.
Yeah, this is called LOD, the limit of detection. It is the minimal concentration by an analytical instrument would be seen. Like if you spray water, you have 1 liter water, you just sprayed, and you added only one small cube of a sugar and shaken and then sprayed. For the sugar, get a very small signal in a particular instrument. That is or 5 times of LOD has been as a limit of quantification. If you see any reports in analytical which says around 10 ppb, less than 10 ppb, that is LOD. And then if they say around 25 ppb or anything, that is already reported results. And SPC, this is a one thing. If you are using the instrument over a period of time for 1 year, there is a particular standard every day it is being repeated to see whether the value is repeatable by itself. Is there any change in the instrument, what is happening? Certainly, certain companies use only one instrument for one type of products at that time they use this, or even then also if they use for different products, they use it. Round robin tests, it is conducted across the different labs across the world, or it may be internal company also. PTS means Proficiency Test Scheme. There is an external body agency like FAPAS, ASTM, all this, they send a external sample to you. You have to test on you in your lab using the instrument and tell them the results. They will rank you across a few companies how you stand. That is the way one will decide how our performance of the instruments are. That comes up to another topic. This is going to be interesting for everybody. Why I will tell you, for all the students, think like this. If you have a 10 grams of sample, you can take and play with, like if you want, I don't know whether you have a qualitative analysis, something like finding what is the ions in this. I don't know what is your curriculum, but when you complete your undergraduation, go to post-graduation, there is a qualitative analysis where you have to find what is the salt. Is it sodium sulfate, calcium chloride? They mix up a few salts and give it to you. They give only a little amount to you. You have to analyze it in that time. Like that, in everyday life, for us as a scientist, we get into limited samples availability. For example, the next speaker may also speak about this when it goes to the clinical trials. Or let me take another example. A baby is born, there is called neonatal studies. Neonatal studies is on the babies they are conducting because of so many elements in the babies. They can take a very less amount of blood out of the baby every day, not too much, because it doesn't produce so much at that point of time. And they have to analyze and get the results in that. With a limited amount of sample, how do you analyze and how do you get accurate results? What are the analytical technologies you can use? This is one of the ways. And every day in research institutes and research organizations, we face this problem, because of so many reasons. And going further also, when you do the research, when you complete your post-graduation, go for a PhD, you don't have a leisure to spend around 50 grams of some material with another 50 grams, make it 100 grams. No, maybe 5 grams or 2 grams, even lesser than that you will produce. We'll land up at around 10 milligrams or 20 milligrams of the impurities. In those cases, how to approach this sample? What are the analytical techniques you can use, and how the data can be predictable? If you take any paper today, any analytical publication, any analytical science publication, everyone uses the instrumentation. Whatever the data they get, based on that, the conclusions are drawn. Okay, how can I proceed? If I have only 10 milligrams of this sample, or let me keep it as 100 milligrams of sample now. I have only this much, I have to tell about this results. How should I go about? First, I take about the non-destructive technique. The non-destructive technique means you can use the material and you can take back and reuse the material. There will be no change in the physical or chemical characteristic happen over there. In FTER, yes, you can do it. In certain cases in NIDACs, there may be a change, but more or less nowadays they do it without any change in the material. NMR, this requires both the solid and liquid samples, but I'll come back to that when I come to the slides of NMR. TGA, this might be a little destructive technique, but the amount of sample required will be very less. Even the DSC, CHLS, means you can complete all this test within, I can say, 20 to 25 milligrams of samples. Hence, you know the thing, you know what is the material out of it by this time, by completing this analysis. And based on these results, then you can pick and choose what is a qualitative or a quantitative method which you can use it for. Sorry, just give me a second. This is blocking. Okay. Okay, you can decide what quantitative methods you can use. GC means gas chromatography. HPLC is high pressure liquid chromatography. GCMS, mass spectrometry, time chromatography, and ICP-MS, which is one of my favorite topics. Coming to real platform, this platform is a invisible radiation in the electromagnetic light, where it has three regions. One is near IR, mid IR, far IR. For a compound, I told the black material in the last slide, if the compound contains some moisture, for example, the moisture has oxygen, hydrogen, two hydrogens, or the water contains this, where the oxygen has a low pair of electrons, which are highly electronegative. Hence, if the charge is on this, there will be a dipole which is created. When any material has a dipole, they are always IR active. And you can, if there is a moisture in the material, you can easily recognize out of it. If any compound containing a double bond with a C and O or COO minus acids or anything, this all absorbs the IR. Why it does to absorb the IR? When the radiation interacts with the molecule, it undergoes a change. It's called bending or stretching. A bond can be stretched out and it relaxes back. And there are n number of molecules, few of them undergoes the change and then they return back to the original state. That makes it an IR active compounds. If I see there are different type of configuration changes, what happens? It's called bending, where the molecule bends inside, and stretching out, where one of the bond gets increased. And rocking is a totally different way of change what it happens. And if you can see what these groups are called to be as functional groups, like acid is COO minus, ester is COOR, or ROOR, where the esters are there, aldehyde CHO. All this has a particular region where they absorb in the spectra. For example, this can be a moisture, or a little higher, it can be NH bond also, NH absorption also. As you can see, 3400 can be a NH absorption in those regions. There is one of these accessories which is known as a zinc selenide. Before I tell about this, I got a permission from the vendors before I present this. Why? Because in any publication or anything, as a company we should have a prior permission from the manufacturer that I can use this material in these slides or in my presentations. Even similarly, I think colleges may not have this route, but anything beyond the colleges, if you are going into a professional life, when there is a copyright signal, C with a circle, you have to write back to them asking, I'm going to use this in my article, is it fine with you? Asking the permission of an author, or it may be publishing house for that. I had asked for the permission for these companies that I will use this instrumentation to showcase what the analytical science can, this instrument can do in analytical science. This is zinc solenoid ATR instrument. This can be taken into the market where you can put the sample over here and tighten up and start the instrument, and it records the spectra for this. It's similar to this. You can get back to the lab, compare the spectra along with the library spectra, and tell whether this is the same material or not. This can be done with the plastic or the food material and all the other things. For example, if you want only this peak to be elucidated, and this is a peak of interest for you in your research, in the next few slides, when I talk about chromatography, you can do the isolation and bring back the sample, which is very tiny milligram. You can put it over there and you get only this peak. That will be touched upon when I come to the HPLC or as a technique. Coming to this told about what are the characteristic functional groups are there in the molecule. That means organic composition. You can see CH, OH, CC bond, CN bond, all this. Now what I'm saying about is SEM EDAX. This is where the interaction of the high energy electrons with the samples. When high energy electrons interact with the sample, the electrons will pass through, which is transmitted, and some are reflected. So the reflected are also known as backscatter electrons, and there is a secondary electrons which are also emitted out in this process. This is about the surface structure, surface information, as well as the element information as well as. The cathode luminescence also says about the element profile of the material, what you have put in there. As I told you, this is black material. See, think this is the same black material which I was introduced. And a small 5 micron size of spot would be utilized to know about the entire information about the material. What happens when the X-rays interact with the material at the atomic scale is when the primary electron bombards, the innermost electron is knocked off, creating a cavity over here. And the electrons from the outer shell jumps in, and the extent of jump or the release of energy, what happens is in the form of an X-ray or the light, which is measured by the detector. This is a characteristic for each and every element. For example, a material contained a chromium and an iron. There are specific wavelengths which are emitted for an iron and a chromium. There may be a very small overlap, or since it's a continuous spectrum, hence there can be overlap, but there are discrete lines which we can choose in the instrument to have this type of measurements done. Well, this instrument can do the quantitative if we have a same reference material, but if not, we can use it as a semi-quant analysis to know about the composition of the material in an approximate way. Like this is a material which was introduced, and the first spectrum corresponds to this portion, and the second corresponds to the black portion of the material, which is seen totally different with respect to that. You can see the carbon content is totally different, oxygen totally different, as well as iron, and to an extent of chromium, copper is totally different in those. This tells you for the further section, when you want to do for quantification, what you have to look for. This may be a semi-quantitative. It can have an error even 50% because there is no reference material for this. Hence, it gives you a direction when you go for a quantification. The copper is very high. I can take a very less material because I know the sensitivity of the mixed instrument. This is a quality decision what you will drive while doing this type of analysis using the EDAX. Coming to NMR, nuclear magnetic resonance spectrometer. As the name says, nuclear, the nuclear interaction with the energy, with the electromagnetic radiations. Magnetic resonance. Resonance is the one which interacts, which resonates when both the frequencies match, it gets resonated. For example, if I take one of the carbon, the carbon, if you don't apply any magnetic field at a room temperature, they have a different orientations for the carbon protons, carbon nuclei. It can be scattered, it can be totally in a different positions. When you apply a magnetic field, the carbon nuclei can align with the magnetic field, and few all will align against the magnetic field. When it aligns against the magnetic field, it requires a higher energy. When it aligns with the magnetic field, it requires a lower energy. And when you apply an RF radio frequency at a certain frequency, what is required, it can resonate. Means to say, it can flip from the alignment to in the reverse direction. Hence, going from the ground state to an excited state. These frequencies are being characterized, and the instrument has the logic to derive those, and we apply these frequencies to get those. Normally, what type of material will interact with in the NMR is proton, carbon-13. Always they should be there in a nuclei. When I say nuclei, it contains proton and neutron. Both should be odd, or one can be odd, another can be even. There should be a combination of odd, even, odd. But if it is an even, it is not a what you can call it is not NMR active. Like carbon 12, carbon has 12. It is not a NMR active. It's carbon 13 is an NMR active, and that brings up, these are the material which is NMR active. I know from the previous slides, I have some information. When I see the C and N, okay, if I get something over in the instrumentation, I can use a solid NMR, solid state NMR also, but this is not a topic of today's. But I have taken one small example to explain out. If you see this is an ethanol structure, CS2, CS3OH. CS3, CS2OH, sorry. These are the three protons that interacts with these two to give the triplet with a higher intensity, because the three protons are there which interacts with these two protons to get the triplet out of this. When these protons interact with the triplet to give quartet, in the sense 1:2:2:1, this is the type of information what we get. And this proton is away from all the other interaction, and there is a bulkier atom over here which is having a lone pair of electron. Hence, it will be in the downfield, you get this. But by using a different megahertz, different what you can call magnetic field, you can shift, the peaks will shift. But over a period of time, when you are doing those experiments, you know what is the chemical shift and how it can predict. Hence, for example, this material, what I was showing, the black material, had some methanol sprayed during the preparation. It can, if you leach it with deuterated solvents, you can get this peak also. Certain metals are also NMR active, and they can be used. They are used for so many reasons in the research. The people uses COSY and TOSY. These are the type of experiment which are called 2D NMR. COSY is the one homolog where the vicinity they can see. This is more the spatial proton interactions they are seeing. This is how, at least with around 10 to 20 milligrams of sample, you can come to know what are the molecules present. What I've shown is a very simple one. They can be very complex one because of the impurities and all the things. Unless you purify in the last step, when I say about the chromatography, I'll tell about that. You don't get this type of clean spectra. This is maybe a solvent which I'm showing, but you don't get this type of clean spectra. TMS here responds to trimethylsilane, which is a marker peak, which is used in always in the NMR. Coming to CHNS, this, if you take 2 milligrams of sample, it tells about the composition of how much C, H, and N and S is there, and even the oxygen can also be done. When you take the sample and put it into the furnace, it oxidizes, converts using oxygen at 950 degrees centigrade, where carbon gets into carbon dioxide, water, nitrous oxide, and sulfur dioxide at a higher temperature. And the copper is used as a reducing agent where the nitrogen is reduced. And using TCD as a detector, you can detect over a percentage of carbons present in this. This is a quantitative technique. We use cysteine, anilides, as a standards for those equipments to calibrate for nitrogen, carbon, hydrogen, and sulfur. With 2 milligrams, if you repeat 3 or 4 times, you know the average and standard deviation. You are fixed with the carbon composition. Then you can look at the NMR spectra. If it is neat, you can decide what splitting patterns are there. Then if you go back and look at the EDAX, you know what are the elements present, what material can be, those predictions can be done. Coming to thermogrammetrical analysis, this is a interaction of material with the heat, how it interacts with the heat, and what are the changes it happens. For example, there was a plastic which was given to me, and I don't know anything about that. But I know my signature of polyethylene, polypropylene, how it degrades. What I can do is do a temperature study or in air or nitrogen or helium. Any gases we can use, or we can use even oxygen or combination of both, such that it gives the characteristic thermogram, which is coming in the next click. TGA, it tells about the deformulation to a certain extent, not to 100%, to a certain extent. What you require is only a couple of milligrams of sample. Hence, it is a very sensitive instrument to quantify. But it also brings up another question. If the sample is inhomogeneous, you can totally go wrong. That is also there. And one has to be very careful about the sampling in those areas. And very micro balance is over here. To tell about this is a furnace where the sample is taken. Earlier, it is loaded onto the pan, and the pan is picked up and it is introduced in this furnace. You can program this to temperature. It can go up to 1000 degrees centigrade over a period of time. The ramping can be determined by you, what the ways it can be done. The gas inlet can be oxygen, helium, as I told you earlier. There is a reference pan. You know the weight. What it does over a period of time when you increase the temperature is this. You get a thermogram like this. When I see my NMR, when I see the last slide, what I presented about carbon, now I decide about how much of volatile carbon are there, how much of middle carbon are there, whether it correlates back to my NMR spectra and my EDAX analysis or not. Whether there is a high molecular compound, it may be inorganic also, it may be totally oxides and other things, or carbonates also in those areas. But nevertheless, what I can say, the earlier equipment should have spoken to you with those type of data where you can predict out and use this data also as a quantification using the standards, and you can decide on the material. You can do the thermal stability of the material, oxidation stability of the material. Means this is the oxidative stability. Over a period of time, I put the oxygen and see how the material behaves. Multi-component analysis. Think it is a volatile compound and a oligomer. What is a oligomer? It is thousands of monomers can be an oligomer. High molecular weight may be a lack of molecular weight compounds can be high molecular weight also. Lifetime of the product. For example, if a plastic says I can use it for 3 years, I can do aggravated studies and tell whether it can last for 3 years. That type of analysis can also be done. Kinetics and corrosive environmental studies. You can introduce oxygen and see whether the corrosion happens or not. That is where the TGA comes into play with respect to relation with the temperature. Coming to differential calorimeter. Here also the requirement of sample is only 2 milligrams to lesser than that, but yes, that brings up, as I told earlier challenge, it should be homogeneous, it should be flattened. In this case, what we do is, this is the cup where we take the sample, put the empty cup here, put the sample. We try to keep the heat from the below and see the change compared between the sample and the references. The heat absorption and what changes happens as a function of time and the temperatures. Here also you can go from negative temperature like -150 till you can go to 400. In a certain case, you can still go much higher to 700 degrees centigrade to get the information. But it becomes a complementary for the earlier technique. But it also speaks about what is a melting point of a polymer or melting point of any compound which is in the mixture, as well as This is called endo curve. And when you bring back the temperature, the sample can condense and it can bring back to its original form. This is where the polymer can melt, and when you bring back, the polymer starts once again forming into a solid. This tells that each and every polymer and each and every material has its own degradation patterns. Hence, it is a characteristic of those. That comes to say about this temperature. And earlier I know the volatility. Before that I know how much of carbon. Now I will decide whether I go for GC-GCMS analysis. If I see the volatility is around 20%, hence I can expect some of the organics in this. Okay, how can I do the organics? Is by GC. Only GC, they have different technique detectors, which I will tell in the next slide. What is gas chromatography? It's a technique which is separates the mixture of compounds. First and foremost, qualification of a compound to do it in this instrument, the compound should be volatile and it should be not a thermally labile. What I mean to say thermally labile, when you heat, it should not break. Certain times we use this as a positive as well as a negative. Positive in the sense, if it forms other product and I can use, and that product is a stable one, I can use that mass for the quantification. I use that also as a positive for using in the GCMS. The mixture of compounds are separated based on the boiling point. That means as you heat, if you have a mixture of methanol and dichloromethane comes first, methanol comes next, because the boiling points are quite different. And when it comes, it interacts with the stationary phase. There is a stationary phase which we use known to be as a column. If I tell about the instrumentation, we use helium gas as a carrier. We inject the sample over here, and the helium takes along with the sample. The in the injector, it is heated. The vapors are passed through the column, which contains a DB5 column, or it can be any type of column, right from the polar to a non-polar medium. And once it starts eluting, we have a detector, which I'll touch upon the next slide. And there is a computer for analyzing those. This is how the instrument works in. You have an injector. If it is a thermal labile compounds, I told, then we do it as a VOC, volatile organic carbon. That means to say we don't heat it in the injector, we directly put it on the columns such that we get the analysis done. And in this case, when the analytes are VOCs, I can use any detectors to analyze, like FID. All organics volatiles at a higher percentage. You can see the ppm to percentage. This can be detected. When you go to the mass, you can go to the lower ones. If you have halogens as a VOC, then you can use ECD as a detector for the quantification. If the compound from the carbon analysis, I see it is a very huge carbon, then I can use a split or splitless. What it means is I can inject entire sample or let few percentage of sample out, and then a low amount of it. And if there is a volatile compounds, this is called programmable variable temperature. This comes as an injector, where you can ramp the injector to a certain stage over a period of time, such that each and every volatile comes out. Like this, there are on the injector, with the injector combination along with the detector combination, you can use this instrument to analyze different type of volatiles. One of this spectrum is done with the mass as a detector. This is the TIC, total ion chromatograph. There are a lot of peaks. You don't know what is what. Now, what happens is you extract 91 mass and 78 mass. From this total ion spectrum, you can extract different masses. You get this mass. And you can see a blue trace and a black trace, a blue peak and a black peak. Black corresponds to 91. When I double click on that, it can go to a library and match the spectrum and tell what is a percentage match and tell what is the analyte of interest, analyte what it has been found. Like this, you can use the mass spectrum as a detection for trace volatiles. Even we do the measures also. As you see, there are a lot of peaks over in this slide. This has a volatility of 40 degrees, and this can be a volatility of around 350 degrees centigrade. And different volatilities compounds we can do in a single shot using those. If the compound is not at all volatile, means to say if whatever you heat, it will decompose, then we use a HPLC, and in combination with the MS, we can identify the different masses. Is it I'm audible? It's totally silent. Just I want to check. And how much time I have? How much time I have?
Another 5-10 minutes, sir.
God. All right, I'll rush up. Solvent is pumped to a pump and injector. Where it's a similar way what it happens in GC, but the column can be in reverse phase where it is a C18 or a C8, and different type of columns will separate different type of compounds. You can use different type of detectors to have different type of quantifications, and more probably PDA is used as a detector, and certain different analytes have different type of sensitivity with RID and ELSD fluorescence detector. Mass is the ultimate detector for everything, where you can quantify very low quantifications at a very low concentrations. Single quad is only one quadrupole. Triple quad is a quadrupole cell and a quadrupole where you can do different gases, different analytes conversion. And QTOF, you can go up to, suppose if the molecular weight is 200.0002, you can still quantify those type of accurate masses. What it says, you can put, suppose if it is questioned in any form or in any agency or anything, you can tell it's a mass, and we have done with the high mass resolution instrument, and we characterize by this. But all the other complementary techniques also will help in checking about the mass accuracy and authenticating those compounds. Ion chromatography, if you have something like chloride, bromide, iodide, sulfate, phosphate, all this in the water analysis, similar, the element is pumped through, sample is injected, it goes through the column where all anions are separated, and this is an instrument which separates out the eluent from the analytes, such that you get a good signal to the signal to noise ratio. As you can see, different type of analytes has been done in a single shot. Certain times it is having a challenges, but nevertheless more or less we can get around 20 to 25 compounds eluted in a single shot. It requires a lot of maintenance also. Coming to my favorite topic, I'll rush upon in 5 minutes. Can anybody see the metals in this?
Yes, sir.
Yes, sir.
Do you see metal in the figure?
No, color is the metal. Color, sir.
Super. Okay. The color ends what we use is also a metal, as Madam said. Yes, correct. It can contain alkaline and as well as transition group of metals. Hence, those are the ones which gives the metal concentration. If the metals are there, how it is being prepared? By open acid digestion. This is an age-old process, and it has a positive, it has a negative. Positive, you can digest easily. Negative, volatile metals like mercury, arsenic, cadmium can be lost to a certain extent. Not everything, may be lost to a certain extent. But certain type of samples cannot be digested by this, something like geological rock or ceramic or a glass. They have to do under fusion around 1000 degrees centigrade. We use the borate, borax combination, and there are different type of fluxes we use apart from this to solubilize different type of materials. Once the pellet is done, we put it back into an acid, solubilize, and then analyze by the instrumentation, or we can take it to XRF directly to quantify those. There are the EPA and FDA came up with a suggestion where volatile volatile metals have been lost. The microwave digestion has to be used, and it has been known from the ages also. The microwave digestion gives you more reproducibility as well as quantification as well as the full quantification to an extent of more than 90% recoveries at a lower concentration of PPBs. PPBs, when I say, is nanogram per ml. ppm is microgram per ml. At those low concentrations can be analyzed. These are the two type of microwave digesters what commercially is used even today. One from CEM, another from Milestone, and this has a very high pressure. What is the use of it? It's like a pressure cooker. If you have a higher capability, you can dissolve more sample of this and a lesser sample in this. But nevertheless, you get to know about the metal content of it. What is the advantage and disadvantage? When you take less sample, when it is very trace, you may miss out. When you take more sample, you may get the signal, but there are a lot of other instrument issues may come. There are, one has to make a trade-off to do those. In the entire process, what you are doing is converting organic carbon with the nitric acid to carbon dioxide and all the metals as a nitrate and take it for the instrumentation. Let me move on to, is there any way which I can analyze the metals without any preparation? I told about SEM EDAX, but there is another way which you can use. This is a paper which has been published with the uranium blood dating with the zirconides. This is called a laser ablation. We can connect with the next instrument which I am going to tell about. It vaporizes the metal surface and it is carried down to the ICP-MS where the metal profile is being seen. As you can see in the picture, sample is taken, a laser is being bombarded, the metals have been transferred into the plasma where the temperature is around 10,000 degree Kelvin. All the metals get ionized and the mass spectrometer tells about it. What is the use of it? Last 2 days back, I was reading a news that there has been one of the rose rubies have been, in this sense, it has been auctioned for 28 million. If it is so precious, can I digest and throw it out? No, it's not possible. In these cases, when the ores are being, or when the minerals are being chosen to screen, they use this technique. A very small amount of sample is being ablated, and we can know about the material characteristic. Coming to ICP-MS, this is the last technique, I think so. It's an inductively coupled plasma mass spectrometer. It can go from lower milligram to nanogram per liter. This is a high sensitive instrument. What is in ICP-MS is a high temperature source which is generated by ionizing the organ, where you get the temperature of 6 to 10,000 Kelvin, where ICP-OS is another instrument which is on this, but ICP-MS has a higher temperature to get ionization. You take the solution. In this instrument, you have to give only the liquids, no solids into this. As I told you, if in laser ablation, you can get the vapors into the instrument. Liquid, it goes into sample introduction system, ionizes, then there is a focus, what you can call quarter pole, then the detection happens. This is what and the cross section of the instrument looks like this. We feed the sample over here, and through the peristaltic pump, all the sample, 10% of the sample goes into the instrumentation through this sample introduction chamber, and we use 27 megahertz of RF. What happens is we strike an electron. When we put the RF, the electrons start rotating, creating a very huge rotation, and the argon is there, which rubs out. Due to the friction, the plasma is seen. Yeah, this is a plasma we see. This is around 10,000 degree Kelvin, where all the metals are ionized. And how it is ionized? When the small droplets goes in, it undergoes dissociation and atomization, and the ions are formed. The ions are extracted into the high vacuum region. Why? Because once you produce the ions at atmospheric pressure, it is not stable. Hence, it has to go through the high vacuum region to be more stable, and it can be analyzed. And in doing those processes, when we digest with the acids like nitric acid and hydrochloric acid, certain molecules forms like argon chloride. Argon is the gas I told you, which I use in the plasma, that can combine with the chloride of HCl, forming 75 mass, which is a highly interference for the arsenic. How can I remove it? As I told you, argon chloride and arsenic, there is a collision cell over here. This collision cell, which removes the this type of analyte interferences from the arsenic, and we can quantify at a lower PPPs to an extent of 0.1 ppm, 0.1 ppb to 1 ppm. That is the lowest range what we can do by this instrumentation. Using the quadrupole of 3 megahertz, which resolves different metals at different time, and it is quantified for the quantification. If you can see the cadmium, as I told you when I was starting my presentation, the food is screened for lead, cadmium, arsenic, mercury, 1 ppt to 1 ppb in one shot, and whereas sodium at a higher percentage. For example, the potato chips, what you eat, can have a high sodium and a low cadmium. It can be digested and done on this equipment. Looking at the time, I skip on some of the slide. There is another equipment where it has a similar configuration, but another quadrupole is added in front of it, such that if anybody is using a titanium reactor and they want to quantify the titanium quality before they build the reactor, these are the interferences when you digest and spray the sample into the instrumentation. By having the first quadrupole and the second quadrupole, you can remove all type of interferences caused by calcium, phosphorus, silicon, and other. You can use a reactive gas which converts titanium into a product. Titanium is a 48 mass and oxygen is 16. You can shift the mass from 48 to something else such that you can remove the interferences and measure the titanium at a very low concentration for the purity. Or else in the other products, if a trace titanium is there, you can as well measure for that. These are the calibration curves for ICP-MS in a single quad and a triple quad. You can see 31 change to 47 using a mass. Similarly, all the other. To conclude, if you have a solid sample, you can use a different technology techniques to conclude on different compositions. And if you have unknown solid sample, which is an organic, you can, if it is less volatile, less than 400 degrees centigrade, you can GCMS, using different analytical techniques, you can identify as well as quantify. If it's more than 400 degrees centigrade, you can take it for liquid chromatography by solubilizing in a solvent and quantify those. Coming to inorganics, if it is an inorganic totally acid soluble, you can take it with MS and ICP-OS, IC, quantify those metals. Or else you can go for fusion, go for XRD and XRF. Totally unknown liquid, it is a mixture of two. You can separate those liquid, take out the moisture by column Fisher. Similarly, the same thing happens of what I said earlier. Boiling point less than 400, you use these techniques to identify as well as quantify. More than 400 degrees, you use this for identification and quantification. Water as a sample. Normally, water has a stipulated, what you can call test to be done. The pH, conductivity, TOC, oil and grease, pH, and bacteria, GCMS for volatiles, anions, cations, and toxic metals for total nitrogen. And some of the, if it is a residues are there, then we use the acid digestion also to see what are those. With this, I stop at this point of time. I can tell one. Being an analytical chemist, you will be the judge to tell the world what is this material. But the whole world looks at you for the answer. Then they give the sample, they look at you, you are the responsible person. It's a pride in doing a job. It also brings as well as a responsibility, as well as what I can say, you undergo a little more drama during when you don't get the analysis done. That is also there. I should be open in telling that. But you are the judge to tell the entire world what is this and using the different technologies. And few papers, when they publish using the data, you feel unhappy that you contribute a little bit to a science. And what your professors and your gurus taught you has fetched something to society. With this, I stop my talk. I think I overshot it. Sorry for that. Hello?
Thank you, sir. Thank you for your valuable words and the information that we have gained. Now I request the participants to put forth the questions. The session is ready for the question and answers. The participants, those who want to ask the questions, can unmute themselves and ask the questions.
Hello, sir. Good afternoon.
Good afternoon.
Hello.
Yes, please go ahead.
Can I ask a question, Megha?
Yes, ma'am. Please.
Okay, sir. I'm Dr. Jyoti.
Yeah.
Sir, I have a question.
Yes.
There are many studies which shows the ability of using NMR spectroscopy to distinguish TB patients, tuberculosis patients.
Yeah.
But could there be any NMR spectroscopy applied for distinguishing COVID-19 patients? Some research on that?
Sorry, ma'am. I will be honest in telling that my specialization is in metals majorly, but I touched upon NMR today to give a knowledge to the postgraduate, the undergraduate students that this is one of the technique. As of what I have studied, I have not seen it. I have not seen that till today, but I'm not sure about completely about the COVID. Sorry, I don't know that.
Okay, sir. Thank you.
Hello, sir. I'm Manjula Esthan from Physics Department, sir.
Yeah, please.
I have a question on thermoluminescence.
Okay.
So, as we know, material will re-emit that previously absorbed electromagnetic radiation when the material is heated.
So, yes.
So, what will be the effect of heating rate on the thermoluminescence glow, sir?
Okay. When you heat any material, anything you heat, you change its composition. Correct. When any material is absorbs the heat, it changes by itself. It may volatilize. If the volatiles are what you can call escaping, then you cannot return it back. For example, when I was talking about polymers, they have a very less volatility compared to anything else. But if any volatile solvent is there, yes, that escapes out. But if you see the thermograms, what I showed to you, it returns back only for one reason, because the entire material stays intact during those temperature transitions. What was your, sorry, I missed the last portion of the question.
What is the effect of heating rate, sir?
Heating rate, okay. Suppose, for example, if you ramp up very fast, you can say small transitions, what it is, what are minute. If you ramp it very slowly, even then also you can miss out those. For those, there is a in this DSC and TGA itself, there is called a modulated way of doing the analysis. Modulated DSC experiments. You can choose those such that the transitions can be easily identified and it recognizes when the transition happens.
Okay, sir. Thank you very much, sir.
Sir, this is Megha here. I just want to ask a question. As we have students of biology stream also, I would like to put forth a question from their side. Are advanced analytical techniques like NMR, do they give full picture of complex herbo-mineral formulations of Ayurveda?
It's like this, ma'am. If you take the entire mixture, as I told you in the presentation, it is a complex spectra, correct? When I come to the last portion but I rushed it, like HPLC, the people will use those HPLC using PDA detector, ALSD, and so many other type of detector to separate out the compounds. Just give me a second. You can see the slides, correct? And just I will take one more minute to explain. Okay, if this was an HPLC spectrum, this was a in Ayurveda you can have n number of compounds in one of the material. If you put all this material into NMR, you get a pretty complex spectra. You will be not able to do it in a year or so. But people uses these instruments like HPLC to separate those using these detectors, and then isolate only this portion of it, then go for NMR such that you get a particular NMR spectra and you can predict out on that. With the complexity, to a certain extent you can do when you know the molecule, but if it is too complex, you cannot do it.
Okay, thank you, sir. Any questions? Any more questions from the participants?
Sir, I have a question. How is this technology useful to common man, or how much has it reached to the common man?
Okay, nice you asked this question. Let me tell about Bangalore situation itself. As a common man, nowadays the water quality is checked. There is an NAPL body, National Accreditation Bureau of Limited or something like that. I don't know complete. NABL is there, and there is another NIH or these bodies. They pick up the water samples unknowingly from. They will not tell to the vendors. They pick the samples. They give it into third-party commercial labs, which have all these technologies. They analyze, and if they find any problem in the production units, they stop at that point of time. And coming to the environmental way, the people have, it's across the globe, it is the problem, where we emit out all the NOx, SOx into the air. Like that, the environmental agency also have the air sampling units. They go, they unplannedly, and they visit them, they take the samples, come back to the commercial lab. They don't tell who is being given. They get the report, they charge the vendors for that. Yes, there have been increase in the quality of life, and I think you might have seen some RO water units which has been established across Bangalore, I think so. Last time when I visited, I saw those. How best is it? That is another question. Or what are the things they have to take care over a period of time? That is another way one can meet have the quality in the water generation for that. This is certainly the food quality, water qualities have been checked when it is come, but it is 100%. I don't have answer today. You know the answer. I mean answer.
Thank you, sir.
Thank you, sir. Thank you all the participants for the wonderful questions, and thank you, sir, for answering all the questions so nicely. Manjula ma'am, shall we move on to the next session?
Megha ma'am. Yes, Megha.
Yeah. Thank you, Arun sir. Now I would like to request Gayatri MP, faculty from Botany Department, to introduce our next guest, Shri Radhakrishna Neelakanta sir. Over to you, Gayatri ma'am.
Okay, thank you, Megha madam. Good afternoon, everyone.
I'm sorry to interrupt. Arun sir, can you please stop the presentation? It's showing you are presenting now, sir. There you just click and stop present. Ma'am, it's okay, ma'am. You continue, ma'am. I'll just ping you.
Okay, thank you. Thank you, Megha madam. Good afternoon, everyone gathered here for today's webinar. Myself, Gayatri MP, consider it a proud moment to introduce one of our alumni from our main college, Sri Jagadguru Renukacharya College, was a resource person for the second session for today's international webinar. Sir has graduated from Sri Jagadguru Renukacharya College in 1994 and completed his post-graduation in cardiovascular technology, Walker Institute of Medical Sciences, Bangalore. So coming to his work experience, sir has a vast experience in the field of Cathlab. Okay, that is the examination room in a hospital. That's for the audience. Clinic with diagnostic imaging equipments. Sir has also worked at Manipal Heart Foundation, Malya Hospital, Manipal Hospital and Medical College as Chief Cathlab Technologist. At present, sir is working as Senior Manager at Sakraworld Hospital, Bangalore, okay, which is a unit of Takshila Hospitals and India's first multinational hospital committed to advanced medical care. Today, we are privileged to have an opportunity to listen to Radhakrishna Neelakanta sir for a healthy heart care and living. On behalf of everyone gathered for this webinar, I welcome you, sir, once again for this session, and we look forward to hear from you. Over to you, madam.
Thank you, ma'am. Thank you for a wonderful introduction. The second topic for the session is coronary diseases and its treatment. I would request Sri Radhakrishna Neelakanta sir to take over the session. Over to you, sir.
Yeah, thank you very much, Gayatri ma'am, for your warm introduction. Can you hear me, ma'am? Hello?
Yes, sir. You are able to hear.
Yes, sir. Yes, sir.
Thank you. Thank you.
Yes, sir.
Good morning, all. Respected teachers and my dear friends. My heartfelt thanks to Dr. Prema Madam for giving me the opportunity for presenting my experience. I am Radhakrishna, ex-student of S.J.R. Today I am presenting on coronary artery disease. As you all know, the coronary diseases are the #1 cause of death globally, and an estimate of 18 million lives are gone each year. This is all because of work pressure, obesity, eating habits, no physical activity, blood pressure, so on. So I know you all are well aware of heart and its diseases, but I will brief you before starting my presentation. Heart is the most hard-working muscle of our body. It pumps 4 to 5 liters of blood every minute during rest and supply nutrients and oxygen-rich blood to all parts of the body, including itself through coronary arteries. Coronary arteries are surrounding the heart, keeps it nourished with oxygen-rich blood. Now coming to the anatomy of the heart. Heart has 4 chambers, 4 valves and 2 great arteries. The circulatory system is made up of blood vessels that carry blood away from and towards the heart. Artery carries blood away from the heart and veins carry blood back to the heart. The circulatory system carries oxygen, nutrients and hormones to cells and remove waste products like carbon dioxide. Now coming to the most common heart disease. People think that there's only one disease. Many of them think like that, but there are so many heart diseases which I have listed here. Is coronary artery disease, heart disease in children, arrhythmia, cardiomyopathy, myocardial infarction, heart failures, hypertrophic cardiomyopathy, and disease of heart valves. Today I am talking about coronary artery disease. If I get a chance again, I definitely talk on the other subjects. Coronary artery disease which is caused due to atherosclerotic that affects the blood flow to the heart. Congenital heart disease is also known as the congenital heart anomaly and congenital heart disease. Is a defect in the structure of the heart or great vessels, that is aorta and PA, that is present at birth. Signs and symptoms depend on the specific type of defect. Next is the arrhythmia. Heart rhythm problems occur when the electrical impulses that coordinate your heartbeats don't work properly, causing your heart beat too fast, too slow, or irregular. Next is the cardiomyopathy. It's a disease of the heart muscle that makes it harder for your heart to pump blood to the rest of the body. But treatment for this is a medication, or we have to implant some battery work devices called as the pacemakers, or an heart transplant is only the treatment. Next is the myocardial infarction, and also called as the heart attack. This is caused when blockage of blood flow to the heart muscle. A heart attack is a medical emergency. Treatment for this is range from changes in the lifestyle, taking medications, undergoing an angioplasty and stenting, and a bypass surgery. Next is the heart failure, sometimes known as the congestive heart failure, a chronic condition in which the heart doesn't pump blood as well as it should. Symptoms in this heart failure is shortness of breath, fatigue, and swollen legs. Treatment for this is taking less salt, limit fluid intake, taking proper medication, and in some cases we have to implant a defibrillator or a pacemaker. And next is the diseases in the heart valves. In this case, one or more valves in your heart doesn't work properly. Your heart has 4 valves, that is mitral valve, tricuspid valve, aortic valve, and pulmonary valve, that keeps blood flowing in the correct directions. Currently, no medication can cure heart valve diseases. Lifestyle changes and medication can treat symptoms successfully. Lifestyle changes and medication can treat symptoms successfully and delay problems for many years. Eventually, you may need surgery or replace the faulty valves. Now coming to my presentation, that is on coronary artery disease. As I had explained to you earlier, heart is the most hard-working muscle of our body, which pumps 4 to 5 liters of blood every minute during rest, and which supplies nutrients and oxygen-rich blood to all parts of our body, and to itself also through coronary arteries. The coronary arteries are which surrounds the heart, keep it nourished with blood. But what causes coronary artery disease? Over a time, fatty deposits called plaque build up within the artery walls. The artery becomes narrow, and this is atherosclerosis. When this occurs in the coronary arteries, heart does not get sufficient blood. In this condition is called coronary artery disease or coronary heart disease. And here you can see the picture of the coronary arteries, which transport oxygenated blood to the heart muscle. The heart requires continuous supply of oxygen to function and survive like other tissue or organ. As you see in this picture, the coronary arteries wrap around the entire heart. The 2 main arteries, the one is the left coronary artery and the one is the right coronary artery. And these arteries can be categorized based on the area they circulate. And you can see the names, they have different names for different branches. So in the next slide, you can see the normal versus the blocked coronary artery. When the plaque gradually increases, may cause chest pain, shortness of breath, and complete block can cause the heart attack. As and when plaque continues to build up in your coronary arteries, you may develop the following signs and symptoms. The chest pain, called as the angina, usually occurs in the middle or the left side of the chest. Angina is generally triggered by physical or emotional stress. If your heart can't pump enough blood to meet your body's needs, you may develop of breath or extreme fatigue. Sometimes a complete blocked coronary artery will cause an heart attack. So if you think you are having any of these above symptoms, call your local emergency doctor. See, many centers, if nearby your houses, even a clinic, when you have these symptoms, please rush to this clinic. And many of the clinics will have is ECG machine or an echo machine. So the doctor will examine you and give you first aid medications and send you to the bigger hospital. So if you don't have any access to these emergency services, have someone drive to the nearest hospital or drive yourself is the only at a last option. So if you have risk factors such as high BP, high cholesterol, tobacco use, diabetes, or a strong family history of heart disease, talk to your doctor and keep follow-up with this treatment. So when you go to the doctor, when you visit a doctor, he or she will ask your medical history and order routine blood tests, and he will also suggest diagnosis tests which includes ECG, echo, treadmill test, and finally when all these tests come positive, he will refer to a coronary angiogram where you visualize the coronary arteries. What is an ECG? It is an electrocardiogram records electrical signals as they travel through your heart. An ECG can reveal evidence of a previous heart attack or one that is in progress. An echocardiogram uses sound waves to produce images of your heart. During echo, doctor can determine whether the parts of the heart walls are contributing normally to your heart's pumping activity. And the next is the stress test. Signs and symptoms may occur most often during exercise. So your doctor may tell you to walk on a treadmill, or sometimes echo is done while you do this exercise, which is called as this stress echo. So based on all these tests, if this test comes positive, doctor will advise for an angiogram to see the blockage in your coronary arteries or how it is the function of the heart. Based on these findings, in all the above tests, doctor may advise you for an angiogram. So where he will insert a catheter to your heart and take pictures of your coronary arteries under X-rays. A dye called as contrast is injected through the catheter, which helps blood vessels to show up better on the images and outline any blockages. I don't know how many of them have seen the Cathlab, and this is the Cathlab where you can see the C-arm. This is the X-ray tube, and this is the image intensifier. And the patient will lie down here, and the doctor will start the procedure, and whatever is recorded through the X-ray tube will be visualized in the monitors, and this will be recorded. The procedures done in Cathlab. There are various procedures done in Cathlab. It may be a coronary angiogram or angioplasty, a peripheral angioplasty, pacemaker implantation, embolization, thrombolization, electrophysiology, radiofrequency ablations, neuro interventions, coronary rotor ablation, and lithotripsy, etc. More than this, we do in the Cathlab. So, coming to our subject, coronary angiography. What is coronary angiography? It is the most accurate means by which to examine the coronary arteries. It requires a surgical procedure called cardiac catheterization during the procedure. During the procedure, the catheters, like small thin plastic tubes, are placed in the artery. Whether it will be done by our radial artery or it is done by the femoral artery, and directed using an X-ray machine to the opening of each of the coronary artery. Usually, now these days we do all the angiograms of the angioplasty through the radial artery because As soon as the angio is finished, the patient can sit down, walk around. Even on the same day, we can discharge the patient. If you do from the femoral artery, patient has to lay down for minimum 6 to 12 hours in the same position, and he cannot be discharged. He should be discharged on the next day. And this is what I explained to you about the radial axis. And this you can see a tube is inserted through the, it will be same as an IV cannula, slightly bigger than that. Through this, the catheter will be inserted and it will be routed through the heart. And this is one of the femoral axis. So the radial or femoral route is commonly used to access the coronary circulation for angiography or angioplasty. The radial route has been shown to be superior than femoral route, which is quicker recovery time and early discharge. And you can see the consumables which we use. These are the catheters which we use in the cath lab for angiograms and angioplasties. And this first picture is the femoral, which has come from the leg, the femoral artery. And this catheter is done from the radial artery. And you can see the picture is come through the subclavian artery and hooked to the coronary. And you can see the pictures of the live pictures of the coronary arteries. And this is the left coronary artery. These are the normal coronary artery, which looks like this. I mean, the catheter is positioned to the coronaries and injected. The contrast is injected. You can see the clear picture of the coronaries and its branches. And this is the right coronary artery. And how the blocked coronary looks. You can see here. You can see the blockages here. And you can see in this also. So this is how the blockages look like. This is the calcium or the atherosclerosis sitting there. So this is causing the blood flow distally. Gradually, if you neglect this, this will get occluded, and this part of the heart will not have blood supply or the oxygen. Next is the multiple blocks, where you can see there are multiple blocks in the left coronary or the you can see in this picture there are multiple blocks. And this I was telling about biometricular pacing, which is called as the cardiac resynchronization therapy. This is used to treat the delay in heart ventricle contraction. When we are not able to do angioplasty or bypass surgery, this device is inserted. And this occurs in some people with advanced heart failure. This device is battery powered, that is surgically implanted under the skin at the subclavian level. So coming to the coronary angioplasty, what we do during coronary angioplasty? See, we insert a wire and then a balloon is placed there. And initially we open up with the balloon and then implant the stent. And this is the metal tubular. It will be like a pen spring, ballpoint pen spring. And when the balloon is inflated there at that position of the block, the stent remains there and wire and the balloon will be removed. And these are the drug coating stents, latest stents, and special drug coating on the stent which gets liberated on at the site of blockage and reduces the chance of reoccurrence. Earlier we had a bare metal stent where there is no drug. Now the latest stents which are coming are coated with drug. This drug is liberated over 6 weeks of time and reduces reblockage of chances of 5 to 6%. Whereas the bare metal stents, there were chances of 25 to 30% of re-narrowing. So now the latest drug-eluting stents are more advanced, and for all the coronary diseases, we are using the drug-eluting stents. So what is an alternative to angioplasty? So alternative to angioplasty will be medical management or a bypass surgery. So what is a bypass surgery? It is a surgical procedure performed to relieve angina and reduce the risk of death from coronary artery disease. So arteries or veins from elsewhere in the patient body are grafted to the coronary artery to bypass the atherosclerotic narrowed artery. So the veins from the leg will be surgically removed and will be bypassed to the blocked arteries. As you see in this picture, the legs, from the veins from the leg are removed, and they are connected from aorta to the, after the block. See, this is a block here, and the vein will be connected distal to the coronary artery so that the blood supply is established. So what are the indications for coronary artery bypass surgery? So patients who cannot tolerate coronary angioplasty and do not respond well to the drug therapy and who has severe coronary artery disease. So after this, they improve the quality of life. After the surgery, the quality of life will be improved, and the increased life expectancy also is more. So when the person is having multiple blocks, we will not do angioplasty. We will send him for CABG, because multiple stent implantation in the heart leads to re-narrowing. So again, the patient has to come to the hospital multiple times and undergo the treatment. So instead of that, when the patient is having multiple blocks, we send him for CABG.
You should not speak like that. Nobody is doing the honorary. Nobody wants to do. Okay, everybody is coming for money only, and they are doing their service.
Hello. Earlier, now recent times, earlier we were using a bypass pump. Now we are doing surgeries without a bypass pump. This is a newer technique with the proposed benefit of lower complication rates. This is the highly specialized technique with good results in the hands of surgeons who perform this surgery regularly. So after this, what all the medications will be given? The patients will be given on aspirin and beta blockers and ACE inhibitors and lipid lower agents. So what are the increases risk in this? So if you see here, why this coronary artery disease is caused? This is all because of high cholesterol, smoking, high blood pressure, diabetes, obesity, alcohol, and physical inactivity. So the cholesterol serves a vital function in the body, but too much cholesterol can deposit in the form of plaque and block them. There are two sources of cholesterols. One is from the food source, and one is made from your body. LDL is known as a bad cholesterol. It has tendency to increase risk of your heart disease. It is a major component of the plaque that clogs the arteries. HDL cholesterol is known as good cholesterol. Higher in women, increases in exercise. HDL cholesterol helps carry some of the bad cholesterol out of the arteries. The normal values should be less than 200. LDL should be less than 100. HDL should be more than 40. Next is obesity. People who are overweight have high risk of developing heart disease. And smoking is very dangerous. It increases blood pressure, decreases HDL, damages arteries and blood cells, and also it increases heart attack. Alcohol consumption in small amount is beneficial, but when you take in large amount, it adds fat and calories and raises blood pressure. And one day we will land up with a gastroenterologist instead of a cardiologist. And coming to diabetes, at any given cholesterol level, diabetic persons have 2 or 3 times higher risk of heart attack or stroke. 80% of the diabetic die from heart disease. So how to prevent this? So prevention is very important. Before you get heart disease, please follow these points. So eat a variety of fruits and vegetables every day. They are naturally low in fat and high in vitamins and minerals and antioxidants. Eat a variety of grain products. Choose a non-fat or low-fat products. Use less fat meats, chicken, fish, and lean cuts. This is not for vegetarians. And switch to a fat-free milk. And limit your intake of food high in calories and low in nutrition, including foods like soft drink, junk food, and eat very less salt, and limit food high in saturated fat like bakery products, which are trans fat and cholesterol, and cooking oils to avoid coconut oil, palm oil, and ghee. And we can use olive oil, groundnut oil, mustard oil, canola oil, sunflower oil, and soybean oil. So what is the rule number 2 for preventing heart disease is exercise. Maintain a level of physical activity that keeps you fit and matches the calories you eat. Serves several functions in preventing and treating those at high risk. Reduces incidence of obesity, increase HDL, lowers LDL and total cholesterol, helps control diabetes and hypertension. Exercise significantly reduces the chance of diabetes and stroke. With regular exercise, blood pressure in those with hypertension will reduce by as much as 20 millimeter mercury grams. So if you are or someone in your family are already diagnosed with heart disease, there's nothing to dishearten. Science has made significant progress. Just monitor risk factors much more aggressively. Eat healthy, walk regularly, watch your weight, quit smoking immediately, keep your weight under control. In addition to improve your heart, health measures are sure to enhance your appearance, and adhere to your medicines and listen to your doctor. So prevention of coronary artery disease, I explained you, control with do a yoga or exercise, control obesity, control diabetes, do regular exercises, control fatty food, control your blood pressure, relax, avoid smoking. Thank you.
Mega madam. Mega madam, can you continue?
Sir, I have a question. So healthy living is the only means of living, but coming to cooking oils, you told coconut oil is not good. But in South India and Kerala, they have been using coconut oil since long ago, and they're quite healthy. So isn't it contradictory to tell that not good for heart?
Now studies, according to the studies, I think coconut oil has high cholesterol. That is the reason I told like that.
Okay, sir.
ಯಾರು ಮೇಘ ಮಂಜುಳಾ ಮೇಡಮ್ ಬಂದ್ರು ಬಿಡಿ ಮೇಘ ಬಂದ್ರು.
Sorry, ma'am. The session is open for the question and answers. Participants, you can unmute yourself and ask the questions. Participants, do any one of you have any questions for sir?
Hello?
Yeah.
Yeah. I was going through a few reports earlier. They use EDTA for ammonium EDTA as a cleansing agent. They pump it through and then clean some of the calcium and other things in case of stones and other things. Is this being done?
No, for calcium, when the calcium deposits are there in the coronary arteries, we do a test. We use an equipment called as a rotablation. I'm not aware of what you are telling, but we use a system called as a rotablation, which drills the calcium in the coronary arteries.
Is it an acidic component? Is that
no, it is a drilling system.
Oh, I got it. Is that it goes through the catheter and then
it will be like a catheter, like a drilling system, which drills the calcium and makes way. And again, what we do is that after drilling, we just open up the balloon and deploy the stent there.
That brings up my question to second question. When you might have seen so many patients with different ways of cloggings and other things. When you drill it out and take out the material out, is there any characterization done and see what are the composition of it in the sense of how much of is inorganic, how much of it is an organic or something like that? Because I was relating to my presentation, and is there any way which we can tell about, okay, A group or O group people will have this type of blockages or something like that? Is there any correlation there?
So now, these days, as I told you, we are using drug-eluting stents. A stent is a stainless steel tube where a polymer coating, like anti-restenotic dye drug is coated on that. So there are chances of restenosis are very less. That is 3 to 4% out of 100 patient. So there are chances of re-narrowing in this drug-eluting stents also, where when the patient doesn't take their medications properly. So at that case, we have restenotic rates. Is this question you're asking? You're clear with that?
No.
I didn't get your question.
If a O group patient, O group blood group people have some type of heart disease, for example, there was a total block of arteries, and even you saw it in AB group type of people or something.
Okay.
Any correlation for the blocks between these two people? Is there any correlation or a common factor in that material which says this type of blood group people have tended to have those or something like that? Is there any research done on those?
No, I don't think so. Based on the see what we do after stenting, it depends on the non-invasive tests like ECG. When we check the ECG, if everything is normal, we discharge the patients. When after the procedure, when patient again complains of chest pain or there are any changes in the ECG, we take him again and do the angiography again and see whether any problems are there. But blood group, I don't think we have done any research on that.
Thanks.
Thank you for the answer, sir. Any more questions from the participant side? Okay, I would like to request all the participants to please switch on your cameras for a group photo. Anusha, are you ready for the photos?
Yes, ma'am. I'm waiting for them to switch on the video.
All the participants are requested to switch on your cameras for a group photo.
Ma'am, it's done.
Okay, thank you. Now I would request Dr. Jyoti ma'am to introduce Dr. Kamala Vaisi ma'am. Over to you, Jyoti ma'am.
Thank you, Megha. It's my proud privilege to introduce Dr. Kamala Vaisi, Associate Professor of Physics, the National College, Basavanagudi, Bengaluru. Madam has PhD in Physics, thesis title, The Development of Modern Physics in India, 1900 to 1930, Analysis. From Kannada University, Hampi, 2001. Madam has PG in Physics from Bangalore University and BSc degree from Bangalore University. She has teaching experience of 29 years in physics at the pre-university and undergraduate levels. Madam's research contribution is vast. To name a few, she has done interdisciplinary work on development of science education, and physics in particular in India amidst of complexities of colonial administration. The thesis was written in vernacular, documented as one of the landmark works in the history of science publications in Kannada. In Vignana Karnataka book, published by Kannada Sahitya Parishat, a government-recognized body for cause of Kannada. Madam has published papers in reputed journals and magazines. To name a few, Women Science Technology, Mahila Adhyayana, Volume 2, Prasaranga, Kannada University, Hampi, 2000. Einstein Life and Works Guide, Lankesh Balaga, January 2006. James Webb Telescope Guide, Lankesh Balaga, August 2008. Colonialism, Science and Scientific Institution, Vignana Karnataka, Volume, Prasaranga University, Mysuru, in the year 2009. Cosmological Constant and Future Universe, Karnataka Rajya Vignana Parishad, March 2015. She has chaptered few books. To name a few, Bauta Vignana, Vignanayana, Samruddha Sahitya, Bengaluru, in the year 2013. Higgs boson and Satya Bose, Vignana Siri, Karnataka Rajya Vignana Parishatu, Bangalore, in the year 2014. Bangalore Science Forum, Vignana Tantragnana, Kannada Sahitya Parishat, Bangalore, 2015. Madam has published 3 books, important one being Digital Kranti Mattu Bharata, translation of the English book Sand to Silicon, The Amazing Story of Digital Technology by Shivanand Kanavi to Kannada, Kuvempu Bhasha Bharati Pradhikara, Government of Karnataka, 2016. Currently working in editorial committee of Science magazine, present in other committees too. International Physics Olympiad and other activities, which includes, she has been invited as resource person at many pre-departure AMS during 2009, 2015 and academic resource person at 46 I4 2015 Mumbai. She was a member of core academic group NGPE examination. Madam has trained many students for various competitions, design, fabrication and presentation of experiments, innovation in science and education. As a resource person, Madam has delivered more than 60 lectures at various national, state level conferences and schools and colleges. As Dean or Director or Convener, she has organized more than 50 conferences, seminar, workshops, rallies for a variety of themes. To name a few, X-ray, laser, image processing, National Science Day, my experience as young researcher, science rally, etc. Present position held outside academia, like Secretary, Treasurer, Governing Council, Executive Committee member, etc. Presently, she is heading as Dean Udayabanu Center for Higher Studies in Science and Joint Secretary of Bangalore Science Forum. She has been actively involved in learning and production of science films, being part of JSS Foundation for Science and Society, have produced more than 20 science multimedia CDs, scripting dramas for theme sustainable development, both the above activities for Vignan Prasad, DST, New Delhi. As an amateur trekker, she has trekked in Himalayan, Nilgiris, Western Ghats, mountain ranges, Sundarbans organized by Youth Hostel Society Association of India. Madam has awards and recognizations. She's been awarded with Kannada Sahitya Parishad for writing PhD thesis in Kannada in the year 2001. Awarded prizes for My Design Development and Execution of Experiments, posters at national conventions, for the service in the field of education by Bangalore Southwest Rotary, 2014. I once again welcome Madam for this international webinar. Welcome, ma'am. Over to you, Megha.
Thank you, Dr. Jyoti, for an elaborate introduction.
Thank you.
Thank you, Jyoti ma'am. Now I would like to request Dr. Kamala Vaisi ma'am for entering the presidential address. Over to you, ma'am.
Thank you. At the outset, I'm extremely happy and I thank S.J.R. College for Women, its principal, staff members and the management for inviting me to be part of the international conference and to give presidential address. Professor Arun Kumar sir, Professor Mr. Radhakrishna sir, Dr. Prema Siddaraju, Srimati Manjula, Megha, Jyoti, all my dear students who are in the program. So it's my, again I say it's my pleasure and privilege. Since 11 o'clock from past 2 hours, we listened to 2 very interesting lectures. The first lecture by Mr. Arun Kumar, the lead scientist, he elaborated on the beautiful aspects and importance of analysis in any scientific endeavor. So I was just listening completely throughout his lecture. So he started from general analysis aspects, standard operating procedures, the various instruments that are involved, and then different methods, the qualitative and quantitative analysis, the importance of it in the chemistry, and importance of general analytical aspects. And he went through various methods, including NMR, NQR, and other instrumentational techniques, and the role they are playing. So various fields in which these analytical tools or methods are involved, and how these the results through this analysis is helping the society or the research field in general, how we can do. So through this, I was relating it to the undergraduate class. If I relate it to undergraduate class, so most of the analytical tools that you have presented, they have been discussed in the classroom. They have been discussed in the classroom as a lesson. We study qualitative, we study quantitative analysis, we study what is NMR, we study what is NQR, we study what is a STM, and so much and so forth. This is an optimal lecture for an undergraduate student to relate himself to the external scientific world and how the world is doing. Because normally what happens, an undergraduate student sitting in the classroom, he feels, why should we study all these things? What is the use of all these things? Many a time I hear such questions from my student. So if they listen to these kind of lectures, then they will be able to relate themselves to the rest of the world and what is going on. In that aspect, it was very informative and a useful lecture. Coming to Mr. Radhakrishna's lecture, who has delivered a wonderful talk on the Cathlab related activities related to heart and other things. He started with what is a Cathlab, what are all the procedures that has been conducted in the Cathlab, how Cathlab and the human life are interwoven nowadays. I use the word interwoven. Okay, so how our lifestyle is interwoven. Apart from that, through his slides, he brought the Cathlab activities live to all of us. How exactly the procedures are conducted in a Cathlab and how it eases our life from the blockages that we had. So this is with respect to these two lectures. However, coming to in general, do we need such lectures? That is the first thing. Yes, we do. When we say yes, we do, the immediate next question is why? Any scientific talk, any scientific lecture, or the students of science in the classroom, you must always ask the question why. Why do we need a seminar like this? It is in order to understand what is going on in the rest of the world and how we can go forward by observing these things. Why do we need to understand? That is the next thing. Science is integral part of our life. We cannot live without science. That has been proved. ಯಾಕಂದ್ರೆ ನಾವು ಹಳೆ ಕಾಲದ ತರ ಸೌದೆ ಹಚ್ಚಿಕೊಂಡು ನಾವು ಯಾರು ಅಡಿಗೆ ಮಾಡ್ತಾ ಇಲ್ಲ. We are all using the gas stove, we are all using electric stove, we are all using the washing machines, we are using toothbrush, we are using every the tool that is a product of science. So science is integral part of life. And now coming to the next important point, I directly jump to the science and society aspect. If we look into the demographic picture, the world as a whole has a population of more than 700 plus crore. Indian population is 140 plus crore. In order to manage this population, we need to apply science, scientific tools. See, science as a knowledge is one aspect. Science as a tool for society is another aspect. And if we look into the world, the developing and yet to develop countries, we can clearly see most of the countries which are good in science and technology, they come under developed countries. It is not just a name or a fact, this one, but if we look into the facts, the countries which are developed, if we can see what is the yardstick for development, if you see, we have to have 2-3 yardsticks: economy and other aspects. If we see, most of the countries which are developed, which have a good economy, they are spending on an average 2.5% of their GDP. That is the gross domestic product for the science and technology. However, we are spending 0.85%. 0.85% looks small, but the amount is huge. But per capita expenditure on science and technology in India is less. But other countries, if you see America or South Korea or Finland, their per capita expenses are more. That clearly defines science has a role to play in development of a country. Then why? Again, why? If we don't do science, don't we do well in the world? At present, the answer is no. We need science. We need science. Science, Vijay Raghavan is the advisor to Prime Minister, scientific advisor to Prime Minister. If I quote his dialogue, and it is also true, science acts as a fulcrum for national development. And a country which is good in science and technology has approximately 5,000 to 6,000 scientific personnel per million population. USA has around 2.5 to 3,000. Finland has around 5,000 to 6,000 scientific personnel per million population. Whereas we in India, it is roughly around 300. Just 300 science and engineers, doctors, all put together for a million population, which is very less. So with this background, we need to do science. We must do science. Therefore, when we get convinced that we must do science, what is meant by we must do science? We must study science, we must practice science, we must contribute to science. So these things and inspirations to these things can come from the lectures that we had, from the kind of lectures that we had today. So in the background of all this, I thank Professor Arun Kumar and Radhakrishna sir for giving a wonderful lecture. And I also congratulate S.J.R. College for Women for organizing such a wonderful program. Thank you, Prema and team, for the program that you have organized. With this, I conclude my presidential remarks.
Thank you, ma'am, for wonderful words. We are privileged to hear you. I would request all the participants to fill the feedback forms which is posted in the chat group. Now I would like to request Nivedita Jubail, Faculty of Computer Science, to render the vote of thanks. Over to you, Nivedita ma'am.
Thank you, ma'am. Good afternoon to one and all. I, Nivedita Jubail, on behalf of S.J.R. College for Women and S.J.R. Education Society, it's an honor to have been asked to offer vote of thanks on the occasion of International Science Webinar in our college. I must mention our deep sense of appreciation to Sri Arun Kumar, Lead Scientist, KSA Analyst, SABIC Technology Center, Jubail, Kingdom of Saudi Arabia, for his explanation on the topic and providing knowledge to us. Sir, we are inspired by your words. Thank you, sir. Thank you a lot. Next, I would like to extend my heartfelt gratitude to Sri Radhakrishna Neelakanta, Senior Manager, Cathlab, Bangalore, for giving excellent coverage over the topic and explaining us very nicely. Thank you, sir. Thank you a lot. I would like to thank Dr. Kamala Vaisi, ma'am, Associate Professor of Physics, National College, Bangalore, for inspiring us and encouraging by your encouraging words. Thank you, ma'am. Thank you a lot. Wholeheartedly, I thank our beloved principal, Dr. Prema Siddaraju, ma'am, for her support and guidance for organizing such an event. Thank you, ma'am. Thank you a lot. I would like to extend my gratitude to all our participants who are strength of this webinar for being with us. Thank you all. I would extend my gratitude to all my colleagues for gracing this webinar. Thank you all. I would like to thank our beloved students for being with us. Thank you all. I want to extend heartfelt thanks to the organizing committee for their hard work in organizing this webinar and making it successful. Thank you all. Last but not the least, I would thank Anusha M for helping us in organizing this event. Thank you, Anusha. Once again, I thank one and all. Thank you. Over to you, Megha ma'am.
Thank you, Nivedita ma'am. It was really a very great pleasure to have such wonderful speakers for today's session. And we are grateful to all the participants who cooperated and made this event a success. Manjula ma'am?
Yes, Megha madam.
Should we terminate the session?
Madam, Prema madam.
Madam. Arun Kumar sir, thank you very much. ತಮ್ಮ ಅಮೂಲ್ಯವಾದ ಸಮಯವನ್ನ ನಮ್ಗಿಟ್ಟು ಸಾಕಷ್ಟು ಪ್ರಿಪರೇಷನ್ ಮಾಡಿ ಒಳ್ಳೆ ವಿಚಾರಗಳನ್ನ ಹೇಳಿದ್ದೀರಾ. ರಾಧಾಕೃಷ್ಣ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ನಿಮ್ಮ ಸಹಕಾರ ಮುಂದೇನೂ ಇರ್ಲಿ. ಕಮಲಾ ಮೇಡಮ್ ಅಂತೂ ನಮ್ಮ ಕಾಲೇಜ್ಗೆ ಅವ್ರ ಸಂಪೂರ್ಣ ಸಹಕಾರ ಯಾವಾಗ್ಲೂ ಇರುತ್ತೆ. ನಿಮ್ಮಗಳನ್ನ ನಮ್ಗೆ ಕಾಲೇಜ್ಗೆ ನೇರವಾಗಿ ನಮ್ಮ ಕಾಲೇಜ್ ಆಡಿಟೋರಿಯಂನಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಬಂದ ಮೇಲೆ ಒಮ್ಮೆ ಅಂತ ಇದೆ. ದಯಮಾಡಿ ಮುಂದಿನ ದಿವಸಗಳಲ್ಲೂ ನಿಮ್ ಸಹಕಾರ ನಮ್ಗೆ ಹೀಗೆ ಇರ್ಲಿ ಅಂತ ಕೇಳ್ಕೊಳ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು. ಕಮಲಾ ಮೇಡಮ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಥ್ಯಾಂಕ್ ಯು. ಥ್ಯಾಂಕ್ ಯು. ಥ್ಯಾಂಕ್ ಯು ಎವ್ರಿವನ್. ಎಲ್ಲ ತುಂಬಾ ಚೆನ್ನಾಗಾಯ್ತು. ಧನ್ಯವಾದಗಳು. Thanks.
Thank you one and all.
Shall I end the session?